What are standard states for chemical energy enthalpy calculations? Imagine trying to compare the energy content of different chemicals, but each one is in a different form or condition. It can get pretty confusing, right? That's where standard states come into play. They are like a common language for chemists to measure and report energy changes in reactions. Standard states set specific conditions so everyone is on the same page. For chemical energy and enthalpy calculations, the standard state usually means a pressure of 1 atmosphere, which is about the air pressure at sea level. The temperature is typically set at 25 degrees Celsius or 298 Kelvin unless told otherwise. For gases, the substance must be at 1 atmosphere pressure, and for solutions, a concentration of 1 molar is used. When it comes to solids and liquids, the standard state is their most stable from at these conditions. For example, oxygen's standard state is oxygen gas at 1 atmosphere and 25 degrees Celsius. Carbon's standard state is graphite, which is a solid form. These standard states help chemists define the standard enthalpy of formation, which is the heat change when 1 mole of a compound forms from its elements in their standard states. Interestingly, the standard enthalpy of formation for any element in its standard state is always 0. This 0 point acts as a baseline, making it easier to calculate the energy changes in reactions. To find the enthalpy change of a reaction under standard conditions, chemists subtract the sum of the standard enthalpies of formation of the reactants from those of the products, each multiplied by their coefficients in the balanced equation. Since enthalpy is a state function, it depends only on the starting and ending points, not the path taken. Using standard states provides a consistent reference point for these measurements. This consistency is especially important in heat transfer and energy calculations because it ensures that energy changes from chemical reactions are measured accurately. It helps in designing chemical processes, predicting how reactions will behave, and understanding energy flow within systems. So, in simple terms, standard states are the agreed-upon conditions that make comparing and calculating chemical energy changes straightforward and reliable.